All right, what we're going to look at today is graphing a phase shift, which is the terminology we use to represent a horizontal shift, left or right, when it comes to trig functions. And we're going to look at a vertical shift, moving it up or down. The phase shift is probably the most challenging of all of them, just because we have to do the most work with fractions here, which I'm confident that you can all do. So we've already talked about what the value of A does. That gives us our amplitude. We've talked about what the value of B does. It gives us our the length of the period, that horizontal stretch or shrink. What we're going to look at today is now we're going to add in this minus C value, and that is going to horizontally shift the starting point. So remember, all the graphs we looked at so far started at 0. We're going to move that starting point off of 0 now, okay? Now, notice that in the formula, it is minus C. And remember, that always means that we need to take the opposite of whatever the number is. So if I see minus pi, then C is actually positive pi, okay? So the way that we determine the phase shift, which is your starting point, the phase shift is C, whoops, that's not a highlighter, C divided by B, okay? And remember I mentioned to some groups, I don't know what I've said over and over again, but anytime we use B, it's in the bottom of the fraction, the denominator. I remember B for bottom. We always divide by B, no matter what it is that we're doing, we always divide by B. So to summarize what we have so far, again, the amplitude is the absolute value of A. The period is 2 pi divided by B. And then the phase shift, our new starting point, is C divided by B. So when we set up our tables now, we have to first figure out where do we start, which might not be 0 anymore. And then when we add the quarter period, we're going to add it to that new starting point, which makes it just a little bit trickier. The rules otherwise are the exact same for sine and cosine, other than, remember, sine starts at 0 for the y values, cosine starts at 1 for the y values. So that's what we have to pay attention to. Okay, so like I said, these are a little bit trickier, so just take your time, go slow, and we just want to be able to work with these fractions. So let's start by identifying our values for A, B, and C. So we have the graph of y equals 1/2 the cosine of 4x plus pi. So we can see here that A is equal to 1/2. That means the amplitude is equal to 1/2. Okay. B is the number in front of the x. That's equal to 4. So that means that the period is 2 pi divided by 4, which is pi halves. That's going to move really quickly. And then don't forget, we need the quarter period so we know what to count by. So that's going to be 1/4 times pi halves, which means we're going to count by pi eighths. Okay, now let's go to the phase shift. C is equal to negative pi. Remember, we always want the opposite of this sign because the formula has a negative in it. So C is negative pi, which means the phase shift is going to be equal to C divided by B, which is going to be negative pi divided by 4. So this graph is going to start at negative pi fourths. It's going to start pi fourths shift to the left. Okay, now we need to set up our table. And I'm going to leave myself a little bit of room to do some scratch work out to the right. Okay, we need to start at the phase shift. So we have to start our x values at negative pi fourths. We need to add pi eighths over and over again. So what I like to do is kind of a scratch work column out to the left. My x column is going to be all my simplified values, but I'm going to convert this to eighths. So negative pi over 4 is equal to negative 2 pi over 8. And so now we're going to add pi eighths to that. That gives us negative 1 pi over 8. Add pi eighths to that. That gives us 0. Add pi eighths to that. That gives us 1 pi eighth. Add pi eighths to that gives us 2 pi eighths. So stick all with a common denominator to start. Now let's come back in and simplify any of the ones that we can. Okay, so negative pi over 8, that does not simplify. 0 does not simplify. Pi over 8 does not simplify, but 2 pi over 8 does. Okay, now we can check pi fourths minus negative pi fourths, the last x minus the first x. And if I subtract that, I do get pi halves, which is the length of the period. So we know we've done it correctly. From here, everything is the same as what we did before. So this is cosine, which means it's going to start at 1, 0, negative 1, 0, positive 1, flip, flop, flip, flop. And now we can take care of the amplitude change. So we're going to multiply all of the y's by 1/2. That gives us 1/2, 0, negative 1/2, 0, and positive 1/2. So we're going to use our x values in purple with the y values in blue. Those make up our ordered pairs. So we just need to sketch out a graph. Our graph needs to go from negative pi fourths to positive pi fourths. So I'm going to put the y-axis in the middle here. And I need, again, 5 points. So it just said to graph 1 period. So that's all we need to do. Negative pi fourths, negative pi eighths, 0, pi eighths, and pi fourths. And I'm going to call this positive 1 and this negative 1. So there's my halves there in between. These graphs don't need to be super precise. This is why I keep saying you don't really even need graph paper. So negative pi fourths is at positive 1/2. Negative pi eighths is at 0. Oh dear. There we go. Bring this up so that doesn't keep coming. 0 is at negative 1/2, then back to 0, then back to positive 1/2. So this graph looks like this. Remember to flatten out at the tops of your hills. Okay. So the stuff in gold, that is the trickiest part because you got to be able to work with the common denominators and set up there. After that, this is not bad at all. Okay. Alrighty. Now let's look at number 9. I'm going to ask you to pause your video, figure out your A, B, and C, and see if you can figure out, just like we did up here, what's the amplitude, what's the period, what's the phase shift. And let's pause and check on that before you move on too far. So pause your video and try that sort of side work, the first part there. All right. Here's what you should have. A is 4, so the amplitude is 4. B is 2, so that gives us a period of 1 pi and a quarter period of pi fourths. C is equal to, remember to take the opposite here, C is equal to positive 2 pi thirds. So the phase shift is 2 pi thirds divided by 2, which is just 1 pi third. So those are all of the pieces. So that means we are going to set up our table to start. I didn't leave myself a whole lot of room. Start at pi thirds, and we need to count by pi fourths. So we need to get a common denominator, which would be 12ths. Now I'm going to have to change both of these to 12ths to make that happen. So I need to multiply this guy by 3 over 3. That makes 3 pi 12ths. And I need to multiply this guy by 4 over 4. So that makes 4 pi 12ths. Now you're going to add 3 pi 12ths, 3 pi 12ths, 3 pi 12ths, 3 pi 12ths until you get 5 points. Then go back and reduce them. So pause your video again and see if you can come up with the 5 x values, the 4 other x values that we need. I'll be back with the answers momentarily. All right, here's what we should get. So again, in gold, we're counting off by 3 pi 12ths. So 4 pi 12ths plus 3 pi 12ths is 7 pi 12ths, and so on and so on and so on. The stuff in purple is what we get when we simplify each of those fractions. This time we are graphing sine. So sine starts at 0, 1, 0, negative 1, 0. And now the final step here is to multiply all of our y's by 4. 0, 4, 0, negative 4, 0. All right, we are ready to graph this. We need to get from pi thirds to 5 pi fourths. Now, again, this is why I didn't give you a graph on this one, because you just sketch it out 5 spots equally spaced. I know that I'm only on the positive side over here. This is just a sketch, so I'm going to call this pi thirds. And then I just want to evenly space 1, 2, 3, 4. There's my 5 points. So this one is 7 pi 12ths. This one is 5 pi 6, 13 pi 12ths, and 5 pi fourths. This is certainly not to scale. Okay, and then I'm going to call this 4, and I'm going to call this negative 4. That's it. We don't have to be super, super precise with these because we're just getting a sketch. So here we go. Pi thirds, 0, 7 pi 12ths, 4, back to 0, down to negative 4, back to 0. There's our graph. Okay. Setting up the x's is the hardest part, but after that, it's not too bad. It's the same process we've been doing. Okay, vertical shifts. We just keep building up the alphabet here. Vertical shifts are going to be plus d or minus d. Okay, now this is exactly the same. Remember when we did function transformations, we said f of x plus or minus h was horizontal and f of x plus or minus k was vertical. When it's inside the function, it's a horizontal shift. When it's outside the function, it's a vertical shift. Exactly the same thing here. Okay, so all d is going to do, and this is plus d, so the sign stays the same. We don't have to flip it the way we do with c. Is we take our graph and we just shift it up or down 1. We follow the exact rest of the process the same. So if there's a phase shift, whatever, work through alphabetically with the values of A, B, C, D. So let's start on number 10. A is equal to 1/2, which means the amplitude is 1/2. B is equal to 1, which means there is no change in the period. So the period is 2 pi over 1, which is just 2 pi, and the quarter period is 2 pi divided by 4, which is pi halves, just the way we did on the early ones. C is also equal to 1. Sorry, that's incorrect. C is equal to 0, which means there is no phase shift. We would have to have, like, in order for there to be a phase shift, there would have to be like plus pi or something inside parentheses, which we don't have. So there's no phase shift. But then D is equal to -1, which means our graph is going to go down 1. Okay, so let's set up our table. Lucky, this is the one that we're kind of used to. This one has no changes to the period or the phase shift. So 0, pi halves, pi, 3 pi halves, and 2 pi. Cosine starts at 1, 0, -1, 0, 1. And let's go ahead and multiply by 1/2 all of the y's. So we get 1/2, 0, -1/2, 0, +1/2. Now you can do this 2 ways. You could make one more column where now you add -1 to all of those values, or we can just sketch the points and then drop them down 1 unit. It doesn't make any difference. So this is our standard graph 0, pi halves, pi, 3 pi halves, whoops, 2 pi. Okay. And let's see, we need probably a couple of marks here. Let's call this 2 and -2. So I'm not going to connect the dots here because this is not our final graph. So we have 0, 1/2. This is cosine, yeah. Pi half 0, pi -1/2. Stop it. 0, and then 1/2. But we need each of these points to drop down -1 because of our vertical shift. So drop this point down 1. It doesn't like when I draw dots. Drop this down 1, drop this down 1, this one down 1, down 1, and down 1. So here is what's different about this one. It's off of the axis now because we've shifted it up or down. So that's it. That's all the different transformations that we could do. We talked about amplitude, vertical stretch or shrink, the period change, horizontal stretch or shrink, phase shift, horizontal shift, and a vertical shift, which is a vertical shift. So you have a second worksheet to be working on today and practicing, and I will see you next time.